Okay, hello everybody. We're continuing with 16b, increasing and decreasing functions. Now, we did one example already, and we want to remember that the function must be defined for all x on an interval before we can classify the function as increasing or decreasing on that interval. So essentially that means we need to take care when there's things like vertical asymptotes or values where the function is not defined. So here we have a rational function, okay, and we first have to figure out what the derivative is and draw the sign diagram, and then figure out where the function's increasing or decreasing. Before we can do anything, when we see a rational function, we have to realize that it is not defined anywhere where the denominator is equal to 0. In this case, the denominator would be equal to 0 when x equals 1. So our first job is to think about all of my asymptotes. Okay, we know that the denominator can't equal 1, x can't equal 1, or my denominator will equal 0. So there's a vertical asymptote at x equals 1. I know it's a vertical asymptote because if I plug in 0 in for the numerator, I'm also going to get 0. And whenever I have a 0 over 0 situation, that is going to give me this. Horizontal asymptote, well, I notice that the degree of the numerator is 1 and the degree of the denominator is 2, which means the denominator is going to increase way faster than the numerator, and therefore it's going to approach a horizontal asymptote at y equals 0. Okay. And last, if we have a horizontal asymptote, we don't have an oblique asymptote, but I do like you to state that just to make sure that you're aware of it. Okay. Now our next job is to find f of x, and we're going to use our quotient law because we have a function divided by another function. So I'm going to take the derivative of 4x, which is 4, times the denominator as is, minus the derivative of the denominator, which is 2 times x minus 1 to the 1, times the derivative of the inside, which is just 1, times the numerator, which was 4x, divided by the denominator squared. I'm going to do some simplifying. So I'm going to common factor out an x minus 1 factor. I'm going to cancel. I'm going to simplify in these brackets and factor out a negative 1. And I'm going to see that this is the expression that I get here. Now, if I want to draw its sign diagram, I'm going to have to continue by setting it equal to 0, following our calculus backup plan. Remember that when I set a fraction equal to 0, I only need to make sure that the numerator equals 0. It doesn't matter what the denominator equals, because the only way this fraction will equal 0 is if the numerator is 0. So I set the numerator equal to 0, solve for x, and I find a turning point at x equals negative 1. Now I'm going to set up my sign diagram, and it's going to look a little different this time. My sign diagram is still going to be a number line. It's going to have my endpoints, which we're not given any other information, so we're going to assume we're going from negative infinity to positive infinity. I'm going to include that turning point on there at negative 1, but I also need to include the vertical asymptote. So whatever on my number line here for my sign diagram, I always include all the turning points and any asymptotes. Okay. Now I can now I've divided my function into some intervals that I'm going to test. I'm going to test values that are between negative infinity and negative 1. So back in my derivative here, if I plugged in a number that was smaller than negative 1, say negative 2, that would give me a negative here, and it would give me a negative value here. So I'd have a negative times a negative divided by a negative, which would give me an overall negative result. If my derivative is negative, it means my function is decreasing. If I pick a number between negative 1 and 1, say 0, then I'm going to have a negative times a positive, because 0 plus 1 is positive, times a negative, because this is going to be a negative expression, raised to exponent 3. So if I have a negative times a positive divided by a negative, I have an even number of negatives and therefore an overall positive result. That indicates that if the derivative is positive, my function must be increasing. Finally, if I pick a number bigger than 1, say 5, I'm going to get a negative times a positive times divided by a positive, which is an overall negative result, indicating my function is decreasing. I can kind of join those points with a little dotted line to get an idea of what my function looks like, but I can answer the question by saying my function's increasing between negative 1 and 1, and it's decreasing from negative infinity to negative 1, and from